So, our whole future with AI, it really boils down to one critical question. In this explainer, we're diving into a paper called The Role of Risk Modeling in Advanced AI Risk Management to see how we can possibly manage the incredible power we're about to unleash. All right, let's get into it. And really, this is the core challenge, isn't it? When we create something with the power to literally reshape our entire world, how on earth do we make sure it doesn't, break it? That's the super high stakes question we're looking at today. I mean, think about it for a second. We get on airplanes, we live near nuclear power plants, and we do it with a pretty amazing level of confidence, right? And that's because those industries have spent decades, literally decades, building these mature, rigorous systems for managing catastrophic risk. They're systems we've learned to trust. But with AI, yeah, we just don't have that yet, not even close. We're building this technology at an absolutely breakneck speed, and we're essentially trying to write the safety manual while the plane is already in the air. It's a bit wild. Okay, so this brings us right to the core problem, what the paper calls AI's dangerous safety gap. Now, it's not like nobody's doing anything. There are a lot of really valuable efforts in AI safety, but the big argument in the paper is that they're all fragmented. They don't really add up to one big unified system for managing risk. And that leaves us pretty dangerously exposed. And here's why this is so tricky. This quote from a panel led by Yoshua Bengio, it's just so powerful. We don't engineer AI models like we engineer airplanes, where we know what every single bolt and wire does. We kind of grow them with tons of data and compute. So without that complete blueprint, their behavior is just fundamentally less predictable. It's a whole different ballgame. So if AI is this totally unique challenge, where do we even start looking for answers? Well, the paper suggests that the path forward is to learn from those other industries, the ones that have already figured out how to solve these kinds of super high-stakes problems. And you know what? The lesson from them is crystal clear. The reason aviation and nuclear power are so incredibly safe today is because they institutionalized risk management. Basically, they made rigorous risk modeling the absolute heart and soul of their safety culture. It's a proven blueprint, and it works. And this slide really highlights that gap. On the left, you see what AI developers often do now. They use things like capability scores, which are kind of just a proxy for how dangerous something might be, or they build these safety cases, which are basically just an argument for why something is safe. But on the right, that's what the mature industries do. They do comprehensive risk modeling. It's a detailed blueprint of all the potential ways things could fail. Okay, so what does this risk modeling thing actually look like? Well, the solution laid out in the paper really comes down to two key pillars. See, proper risk modeling isn't just one thing. It's about the tight integration of two separate but equally important parts. First, you have to map out all the possible scenarios, like the step-by-step ways a disaster could actually happen. And then, second, you have to estimate the odds. What are the chances that it will happen? So that first pillar is scenario building. This is where you get super specific, detailing the exact chain of events that takes you from a potential hazard to real-world harm. And the second pillar is risk estimation. That's where you put numbers on it. And you absolutely need both. I mean, scenarios without numbers, they can't really guide your decisions. And numbers without scenarios, they're just a bunch of disconnected data. Right. I know that might still feel a little abstract. So let's look at a concrete tool that experts use for that first pillar, building out the scenarios. Okay, so this is what's called a fault tree analysis. And it's kind of cool because instead of starting with a cause, you actually start with the disaster itself, the top event you really want to prevent. In this example, it's a massive AI-driven disinformation campaign that destabilizes an election. Then you work backward. You ask, okay, what has to happen for this disaster to occur? And in this case, two things need to happen. The AI has to generate incredibly convincing fakes, and the human oversight has to fail to catch them. This whole structured approach, it forces you to find the exact weak spots in your system. But, effective risk management isn't just about one single method. All the really mature industries use this kind of dual approach, where they balance two totally different ways of thinking about safety: guarantees versus probabilities. And this is a really key insight from the paper's research. It's not an either-or choice. The safest systems on the planet are all built on a blend of two different safety philosophies. So the first one is deterministic safety. Think of this as the non-negotiable red line. There are just some outcomes that are so catastrophic that their probability has to be zero. Period. For these absolute worst-case scenarios, you need a rock-solid guarantee that the system can handle them. It's a simple pass or fail, no middle ground. And the second one is probabilistic safety. Now, this is about mapping the entire landscape of what could happen, not just focusing on those absolute worst-case scenarios. The goal here is to get a realistic estimate of the odds and the impact of all the different ways things could go wrong. That way, you can prioritize your resources where they'll do the most good. And a fantastic real-world example of this kind of probabilistic thinking is the UK's National Risk Register. What they do is they take all sorts of potential disasters, everything from terrorism to accidents to pandemics, and they actually plot them out on this matrix of likelihood versus impact. This lets them see the whole risk picture all at once and decide, okay, where do we really need to focus our attention and our money? Okay, so how do we pull all of these ideas together? You've got risk modeling, you've got deterministic guarantees, you've got probabilistic assessment. How do we make that a workable system for AI? Let's take a look at the framework the paper proposes. So, this proposed model creates a really clear division of labor. On one side, you have the AI developers. They're responsible for doing that rigorous risk modeling to produce concrete estimates of how likely something is and how bad it could be. Then you have the regulators. Their job is to take those estimates and compare them against risk tolerance thresholds that we as a society have already agreed on. It's a system that's built on clear accountability. So the path forward really breaks down into three key areas. First, we've got to sharpen the tools. That means developing better risk modeling methods that are actually designed for the weirdness of AI. Second, we have to settle the rules. We need a real public conversation about who is responsible for what and what level of risk we're actually okay with. And third, we need to push the research on provably safe AI, systems that can give us those non-negotiable deterministic guarantees we talked about earlier. At the end of the day, the goal of all of this is pretty straightforward. It's to move away from our current kind of fragmented approach and build a truly mature risk management regime, one that is rigorous in its methods, totally transparent in its assessments, and accountable to all of us for the safety of these incredibly powerful technologies. Which, it leaves us with this final, absolutely critical question. If we go all the way back to that first idea, if advanced AI is truly grown and not designed, then the challenge is just immense. How do we build the guardrails now, before this technology completely outgrows them? That is the challenge we have to solve, and we have to do it urgently.